Alright, Assalamualaikum. So welcome guys, welcome again in my channel. So like the previous videos, we still discussing about ACS exam. Right now we are in topics about we are in topics of electronic structure, which is it contains kind of like electron configuration and then a bit of quantum. So now we are moving on to another question. So if you want to take a look at previous question, you need to like just watching my previous videos about before it. So I already explained kind of like a bit of concept over there, so just take a look at that video. All right, so as usual, I'm gonna do explaining all of those equation with some way, like using the kind of like various way. So first of all, I will give you a key concept of that one. So if we are facing another type of question but still using the same concept, we can solve that problem rather than just memorizing the type of the question. We want to delve into the concept. Okay, and then the other part is we not only using the key concept. If we can approach that question logically, using our thinking, like think logically, okay, we will do it. And then we can do elimination as well as like just pick up or maybe we can just pick which one that correct. Okay, so let's get started for the next question. Okay, there is a question over here. We are asked which electron, okay, which electron configuration correctly describe a zirconium ion with +2 charge in its ground state. Okay, so as you can see, the question is, what is the ground state electron configuration for zirconium 2 plus? Okay, with the zirconium 2 plus. All right, how to solve this problem? First of all, I will give you the concept. The key concept here is zirconium, okay, has atomic number. We need to think about every single question that we already discussed. We start from what's the where is this element in the periodic table. So we can take a look at the characteristic, the molecule, the weight or the mass, and we can also take a look at the number of proton based on the atomic number and other stuff. Okay, so we know that in the periodic table, the atomic number the atomic number of zirconium is 40. So it happen if its natural atom, okay, it occur when it's for neutral atom for 40, but over here we have 2 plus. Okay, we have 2 plus. So we can do first for neutral configuration. Okay, remember, we need to determine the atomic number first, and then after that to find out the electron configuration. Okay, so what is the ground state? So electron configuration for neutral, remember, for neutral configuration, for neutral first. Okay, so remember, when we are facing the question about this, we have the concept of over here. We can see the option. So of every single option over here, like started with the KR. Okay, KR. Okay, so we can do something like this one, zirconium KR, and then what's else? Okay, what's else? Or you can do kind of like same like the previous one that I show you guys the previous question. So we have like this concept over here. Okay, we have kind of like this concept. Okay, probably we can the one thing that we need to remember, I don't like to memorize everything, so probably better, okay, probably better if we are trying to use this concept rather than just memorizing. Okay, this one might be this one, this one another one, so it's quite complicated. Okay, but sometimes is very easy for us if we already understand like how it looks like for electron configuration. But over here, assume that you suppose you don't have any kind of like memories of this one, so we can develop one by one. So 1s2, okay, 2s2, 2p6, 3s2, 3 4 6. Sorry, we can write it down over here. 1s2, 2s2, 2p6, 3s2, and then 3p6, and then what else? 4s2, 3t10. Okay, so overall over here is like 30 right now, I think. Okay, yeah, it should be 30, and then 3t10, 4p6, and then 5. So over here it should be 5, right? 5s2, and then 4d what? So it's kind of like how much it is, how many it is, 30, 36, 38, and then we have 40, 38, so it should be just 42. Okay, 42. All right, so we already got the answer for S2, for D2. Okay, if you remember the concept of it, okay, if you remember the concept of it, so we can like rather than writing the long chain kind of like this long configuration, we can use the simple way, just KR, okay, KR, and then F4S for D2. Okay, but remember this one is for neutral configuration. Okay, this one for neutral configuration, not for like not for the ions. Okay, so now to know the zirconium 2 plus, we must remove, okay, because 2 plus, okay, lost 2 electron, so we have to remove 2 electron from this configuration. Okay, remove 2 electron. So which one that we need to remove, S or T? The equation is no. Here is something so important that sometimes it might be tricky, because okay, maybe we are thinking that okay, just take out from the last configuration, which is 42, but actually not. Okay, when forming cations, electrons are loose from the highest energy level first. Okay, which one that the highest one? So as you can see, this number, okay, this number describe your energy level. Okay, this number describe your energy level. So based on this information, we can understand which one that we need to take out. Okay, so which mean, because electron, okay, electron from cations, okay, from cations, okay, so we need to take out or remove from the highest energy level, remove the highest one, okay, which is 5. Okay, should be in 5s electron, which mean 5s electron are removed before 4d. Okay, so when we are when we understand this concept, we gonna get the correct answer. So we remove this part, Fs2. So we remove 2 from electron configuration. So it might so removing 2 electron gives us like 4, just like Kr 42. So the correct answer should be B. Okay, so as you can see over here, this is the correct answer for that one. Okay, hopefully we can understand correctly, and then remember we have to take out or remove the electron from the highest energy level first. Okay, when we are saying the was that for the cations. Okay, all right, and then there is another question again, which atom. Yeah, we are moving to another question. Okay, so we are moving so just recap. Okay, always remove electron from the highest principal quantum number first, even if the orbitals are written afterward. Okay, even there is a 4d orbital afterward. Okay, and then now let's head to the next one, the next question. Which atom or ion is paramagnetic in the ground state? Okay, so we are asked to find out which atom or ion has unpaired electron. Okay, unpaired electron. So the key is here. The key is in this word, paramagnetic, which means unpaired. Okay, unpaired electrons. Okay, unpaired electron. Remember, paramagnetic, para is unpaired. Okay, and magnetic is pair. Okay, so so the concept is okay, the concept is, if we are saying the question about paramagnetic, which means this one has like at least one unpaired electrons. Okay, what does that mean? So when you are take a look at the concept of the hybridization stuff, okay, so you will saying something like this one, this one, this one, or this one, or something like that, and then this one, and you will see kind of like probably kind of like this one is the concept of it. Okay, and then paramagnetic, and then the opposite one is the diamagnetic. Paramagnetic, diamagnetic, okay, which is pair electrons. Okay, pair electrons. So now look at their configuration to find out who has unpaired electron. Okay, now we need to find out the configuration, their configuration, to find who like has unpaired electron, all right, so how to do that? Let's go through each option. Okay, let's go through each option. Okay, for the option one, Fa iron, iron is 3 plus, and then based on this concept, we will see the configuration is AR. Okay, I need to take a look at the periodic table again, because this might be much more easier for me. Okay, so if you are looking at the periodic table, guys, you will see, okay, you will see, let me bring this up in our videos again. So let me bring another one, Windows capture to, and then select the periodic table. Okay, let me bring another one. Periodic table, periodic table. Okay, I don't remember. We don't need to remember everything. Okay, So just remember the key concept behind it, how to interpret that one. This one is so important rather than like memorizing all of them. Okay, hopefully this one work in the scripture too. Then okay, it worked now. We'll see from here. Okay, in the periodic table you will see from here, okay, that okay, you will see the periodic table of the iron. Okay, this is the iron, and then there is a AR over here. Okay, AR over here. So how to deal with this problem? It should be easy for us to understand. Okay, I will just make it smaller. Okay, make it smaller, and then I need to take a look at here. Here. Yeah, hopefully it give us much more bigger picture. Okay, so AR, the electron configuration is like for the neutral. Okay, again we have to start from neutral first. All 4s2 and then 3d6. Okay, so if you are take a look at the AR is 26, right? 26. So over here is 18. Okay, AR is 18, and then we need to add how many that we need to adding over here, how many 18 and then 26, so it should be 8. Okay, it should be 8. So over here we start from 4. So this one is 3. Okay, this one is 3, and then here we start from 4s. Okay, 4s2, this one is 4s2, guys. This one is 4s1, 4s2, and then 4s1, 4s2, no, 4s2, and then 3t1, 3t2, 3t3, 3t4, 3t5, 3t6. Okay, kind of like this one. And again, because we need to remove 3 plus, we need to remove 3 electrons, so we can remove this part and then remove one part from 1 electron from 3d6. So the configuration of FA is AR 3t5. Okay, AR 3t5. Okay, so if you are take a look at this part, so you will see in the d orbital 1 2 3 4 5. Okay, 3t5. Okay, because this one is d. Okay, so this is minus 2 minus 1 0 plus 1 plus 2. So it will be kind of like this way. Okay, so all of them unpair, so we can conclude the answer is should be A. Okay, the answer should be A. However, we can take a look at another one. Okay, so if we are not sure what's the answer, we can go through one by one. But remember, we have like time limited. Okay, we have like time we don't have much time. Ooh, so we just have like limited time. So please be consider about this one. Okay, consider about the time that we have. Okay, during the exam, if we are getting the answer, just do it. I mean, just choose it, and then if we are sure, we just choose it. If we are not sure, and then we still have much time, we can we can do more exploration. Okay, we can do double check. All right, and then now we need to understand one by one. So now scandium. Okay, scandium. Okay, scandium 3 plus, so it has AR again, AR. Okay, and then I need to make it bigger. Okay, AR 21, so it should be for S2 and then 3T1, because AR again, AR is 18, so 20 and then 21. Okay, but we need to remove 3. So all of those is removed. Okay, all of those are removed, and then now it should be same with the AR, which is the all of them like no electron, no electron left. Okay, no electron left, so no unpaired electron. So this one is diamagnetic. How about the zirconium 2 plus? Okay, sorry, zinc 2 plus. Okay, zinc 2 plus. Okay, with the same concept like previous one, so it should be AR. Okay, and then for S2, and then for 3T10. Okay, for S2 3T10. Okay, so as you can see, zinc is 30. So this is 18. Okay, 18, 20, and then 30. Yeah, that's true. And then we remove 2 over here in the S, in the highest orbital energy level. So we just have we only have 3D10. Okay, so 3D10 is fully paired. Okay, 3D10 is fully paired, so it should be diamagnetic. And then the last part is Ca. Okay, the last part is Ca neutral, calcium neutral. Okay, so it should be AR. Okay, and then for S2, which is if you take a look at the or S orbital is just 1, so it like fully paired in the S orbital. Okay, so the answer, the exact answer, the correct answer is iron at 3 plus. And then because as you can see, all of them is diamagnetic except the A option. Okay, just remember the concept, how we deal with this equation. All right. Got it. So we are moving to another question again. Okay, hopefully we can finish for electronic structure, and then we are moving to another part which is about the stoichiometry stuff. All right. Okay, so now we are moving to another part. Okay, let's take on this two periodic trans question. Okay, so this one is like a periodic trans question. Okay, so question number 8, yeah. In which atom does a 2p electron experience the greatest effective nuclear charge, or ZEFF? Okay, so this question we are paying us, okay, we are paying us over here, which atom has the strongest pull, okay, strongest pull from the nucleus on its 2p electron. Remember, we have the nucleus, okay, we have the nucleus which contain the neutron and proton, right? And then we have electron that orbit around it, okay, that orbits around it. So this question asks like which one that has the greatest effective nuclear charge, that the strongest pull from the nucleus itself, okay, the strongest pull from the nucleus, okay, the strongest pull from the nucleus, which one? Okay, from the configuration. Okay, remember, we are being asked which one from this element that has the strongest pull from the nucleus. Okay, so how to solve this problem? We need to we need to know the concept behind the ZEFF. Effective ZEFF is the effective nuclear charge. Okay, effective nuclear charge, or ZEFF, is, okay, the net positive charge, okay, the net positive charge like feels that an electron feels fills from the nucleus. The nucleus. So like gravitation, like maybe we can assume this one kind of like gravitational force. So between Earth to a sun, between Mercurius to sun, something kind of like this one. Which one that has the strongest pull from the nucleus? Okay, it's calculated roughly by ZEFF is calculated roughly by Z minus S. Okay, Z is the number of proton. Z is number of proton. Okay, and then S is shielding. S is shielding. Okay, now we understand there is a concept that across the period, okay, across the period, remember, across the period from left to the right, okay, across the period, left to the right, remember, period is left to the right, group is from the top to the bottom, okay. All right, so ZEFF, the concept is ZEFF is increase. ZEFF is increase. Okay, so which mean more protons. Okay, as you can see when we are take a look at the part sorry, okay, so let's take a look at the periodic table. So when we are saying the, for example, from the periodic table, cobalt, okay, cobalt has more proton rather than calcium. Okay, cobalt has more proton rather than calcium. Okay, so so from the left to the right, the ZEFF is increasing. Okay, the ZEFF is increasing because more proton, but shielding stays about the same. Okay, more proton, and then shielding, okay, shielding stays, okay, stays about the same. Okay, the shielding force is about, like, the shielding part is about the same, or like similar. We can say this one is so similar. Okay, the shielding is similar, but has more proton. Okay, but has more proton. Okay, remember this concept of the ZEFF. Okay, remember ZEFF, left to the right. Okay, the ZEFF will be increasing. Okay, will be increasing. And then the shielding, okay, it has more proton, which has more proton, and the shielding stays about the same or similar. Okay, now let's evaluate the option one by one. Okay, PCF and T. Okay, PCF and T. Okay, we can use the we can use the periodic table again over here based on this concept. Okay, I will show you here how to use this periodic table. Yeah, so the concept I already explained, right? The concept how to solve the problem. Let me make it smaller again, and then okay. All right, where is the periodic table? Okay, yeah, that's this one. Okay, this one. Yeah. All right. So in this periodic table, as you can see, B, where is the B? B, C, the option is B, C, F, and N. Okay, all of them, okay, all of them in the period 2. Okay, in the in the period 2. Okay, left to the right in the period 2. Okay, they are all in period 2. They are all in period 2. They are all in period 2. So how to solve this problem? So for the A, like I mentioned before, okay, ZEFF will increase when the I mean when from the left to the right. So which one that most the left? Most the left is F, right? It should be F. It should be F. Okay, it should be F because the concept is kind of like this one. So but remember, we if just memorize a bit part of this concept, like ZEFF increase left to the right. Why? Because it has more proton. Okay, because it has more proton, but the shielding stays about the same. Okay, stays about the same. Okay, remember that one. This is the reason why. Okay, the reason why left to the right tends to increase. Okay, tends to increase. Okay, because of more proton, and then the shielding kind of like the same. All right. Okay, so the answer is F. Okay, same shielding but more proton or stronger ZEFF. Okay, so just recap. Okay, just recap for this question again. That was that the just recap ZEFF. Okay, increase left to right. Okay, in the period. Okay. All right, so now on to the next one, on to the next question. Okay, next to the next question, move to the next question. Okay, which atom has the largest atomic radius? Okay, all right, we are being asked which of these atom takes up the most space. Okay, we can reinstate. Okay, we can restate that which one of this atom takes up the more space. Okay, the question is about the largest one. Okay, the concept. Okay, the previous one we are talking about the ZEFF. Now we are talking about the atomic radius. Okay, the atomic radius. Okay, remember the concept is atomic radius. The atomic radius increase, okay, increase down a group. Okay, because of what? Because more electron. Okay, more electron shells. Okay, more electron shells. Okay, and then atomic radius decrease. Okay, decrease left to the right. Okay, left to right. Okay, left to right. And then because of what? Because stronger. Okay, stronger nuclear pull. Stronger nuclear pull with more protons. Okay, so you can imagine in the period more, like when we are going to the right, I mean when we start from left to the right, the proton will be increasing, right? The proton will be increasing. So when the proton will be increasing, which mean we has much more force for each cells. Okay, for each cell. If we so I will throw it for you. So I will illustrate this one kind of like this. This is the nucleus, and then you have the shell over here. Okay, but if we are looking at left to the right, we will have more proton. So for example, we have like kind of like a bunch of proton over here, and then we know from no, sorry, this is electron. Okay, so if we will have like more proton over here, so which mean the stronger nuclear pull with more proton, this kind of like element will have much more stronger pull from the nucleus. Okay, because we have much more proton, which is it will like shrink the shell or the orbital of the electron. Okay, not shrink actually, but like kind of like has a more stronger pull, like I mentioned before. Okay, and then the if so that's why when we are going to, I mean, that's why when we see the from the left to the right, the atomic radius will be like decreasing because of like has much more stronger pull from the nucleus. And then if you are going to down, okay, top to bottom, okay, in a group, okay, it will increase. It will increase. Why? Because it will have much more shell. It will have much more shell. Okay, this concept, like I mentioned, this concept, it will like produce much more proton, and then this is your cell. Okay, this is your, sorry, this is your cell. This is your cell, and then it will give the more pull. Okay, it will give more stronger pull from the nucleus, okay, to the shell. Okay, so it will be shrinking. Okay, but however, for this another concept for the atomic radius, it will like increase your cell. Okay, you will have like more electron shell, which is you will see kind of like this one. Okay, this is one, and then just right now it has two, or it will have three. So it will much more bigger than the previous one. Okay, remember, for top to the bottom, the radius will be increasing because more electron shells. Okay, but for the row or period left to the right will be decreasing because we'll have much more proton. Okay, causing the stronger pull from the nucleus. Okay, stronger pull with more protons. Okay, so which one the largest one? Okay, which one the largest one? So simply, okay, I will drop it here. Okay, for the radius. Okay, for the radius left to the right tends to decrease. Okay, tend to decrease, and then top to the bottom tends to increase. So we are going to choose, or we are prefer choosing in this part. Okay, in this position. Okay, in this position. Let me, okay, in this position. Okay, in the most down, and then the most left. Okay, so when we are take a look at the periodic table again, we will see, let me bring up the periodic table again. Periodic table. All right, I just want to save one periodic table, the good periodic table. Okay, this is in on the Wikipedia. So as you can see, right, which one that has the position like most the left, and then most down. Okay, which the position is the lowest down, and then the lowest left. Okay, or the far left and then lowest down among the choice. Okay, which one? So the option here is like K, and then I, and then RP, and then SN. Okay, SN. So if you are take a look at the question, so this is K, right? This is K, and then RP. Okay, so RP is like all of them, I think, on the left. Okay, all of them, no, all of them on the left except the SN, and then accept the I. Okay, So most of them in the left is only K and RP. So which one that the lowest down over here? So we can take a look at. So it should be RP. Okay, it should be RRP. Okay, remember it should be RRP. Okay, see, yeah. So yeah, based on this information, the answer is RP, rubidium. Okay, rubidium. Okay, if we are looking at this one, this is I. Okay, and then this is SN. Which one that SN? Okay, right. But the lowest one is rubidium over here, and then this is the potassium. Okay, the potassium is the above the rubidium. So we want to get the lowest down and then the most left. Okay, so it should be RP the answer. Okay, should be the RP for the answer. So yeah, we done for this part again. Okay, we done for this part. Okay, all right. Now moving to another question again. Right, so hopefully we can understand step by step. Okay, so I hope by studying this concept we can understand much more easy. And I also need to learn about this because of kind of like this one, kind of like the basic one. Okay, basic one. Okay, just recall what we already did. Okay, just recall briefly what we already get over here, that that paramagnetic is unpaired electron, diamagnetic is paired electron. Okay, this is the concept. Okay, and then ZEFF, okay, or effective nuclear charge, tends to decreasing. Okay, tends to increase from left to the right. Okay, from left to right. Okay, because of more right, which mean more protons, and it causes the like stronger pull of the nucleus. Okay, and then we also understand about the atomic radius. So from left to the right, okay, from left to the right will be decreasing. Okay, because more proton, stronger pull from the nucleus, and then it will like decreasing the radius because it has strong puller. Okay, strong pull from the nucleus, and then from the top to down, okay, it will be increasing because it has more electron shell. Okay, it has more electron shell. All right, so now we are moving to another part. We are moving to another question. So still same, the concept of the periodic table. Okay, the concept of periodic table. Okay, so the question is, which pair correctly shows the size difference between the species? Okay, from the species. Okay, lithium plus Be2 plus, lithium plus more than Na plus, and so on. Okay, so we need to choose the pair where the larger species is correctly placed. Okay, is correctly placed. So we need to know. Okay, we need to know the size. We already talking about the atomic radius, and then it should be like pretty similar. Yeah, pretty similar concept with the atomic radius. But however, over here we have like cation or anion. Remember, we have cation and anion. This is another concept again. So we couldn't solve by using the previous concept, which is we can determine the atomic radius like from to the left to the right decreasing, from the top to the bottom to down it will be increasing. No, yeah, it's still helpful, but remember, we have another concept about the cation and then anion. Cations and anion. Okay, the key concept over here is cation, positive ions are it should be smaller. Okay, smaller than neutral. Smaller than neutral. This is the concept. Cation smaller than neutral. Why? Why? Okay, why? The cation is positive ion, right? Positive ion. Okay, remember, this is the nucleus containing proton and neutron, and then this is the orbital. This is the shell contains the electron. So remember, if cation, like, which means it lost one electron. It lost one electron. Okay, for example, it has 3, but now lost one electron. Okay, now it lost one electron. So now, before that one, the ratio probably, for example, the proton is, for example, 3. Okay, for example, 3, and then the electron is 3. The previous one, the proton 3, the electron 3. Now we decreasing the electron, we lose one electron, which means the nucleus can pull much more rather than the previous one, because now you can imagine kind of like you withdraw the rope, 3 from 3 people against 3 people, and then it looks like draw. Okay, it looks like they have similar energy, similar force, and then you lose one person in your team. And then if you lose one person in your team, it will, another team will can easily withdraw you. Okay, it will easily pull you towards this, toward the, for this case, toward the nucleus. So it much more smaller. Okay, it might cause smaller size. And then how about the anion? Anion are larger. Because of what? Because it has much more electron. So now, because it has much more electron, so another team over here, as it has 4, and then in the nucleus just have 3. So it can pull much more longer radius. It's much more longer distance. Okay, so larger than neutral. Okay, and then more positive. Okay, and then we have concept again, more positive, smaller. Okay, more negative is larger. Okay, so size increases with the fewer protons and more electron. Okay, size increase with the fewer protons and more electron. Okay, because like I mentioned, adding electron increase repulsion. Okay, adding electron increase repulsion, so it like getting bigger size. Okay, it's bigger size. Okay, so now let's take a look at one by one the option. So lithium and Be. Okay, lithium and Be, put R in the period 2. Okay, put R in the period 2. Again, we need to take a look at the periodic table. Okay, over here we can see I make it bigger again. Lithium and beryllium. Okay, lithium and beryllium, it in the same period. Okay, in the same period, but Le, lithium, has +1. Okay, Le has +1, while Be has 2 plus. Okay, so if we are looking at the electron configuration, Le it has 3 proton. Okay, 3 proton. Be has 4 protons. Okay, and then Be lose to electron, Le lose one electron. So remember, more positive is smaller. More positive is smaller. Okay, more positive is smaller if the element is same. Okay, if the element same. So now we can see Pe has 2 plus charge, smaller than Le plus 1. So it should be correct for the first option. Okay, let me bring another sample over here. Where is the another example? Yeah. So which one that correct? Okay, which one that correct? Like I mentioned, it should be A. Okay, it should be A. Let's take a look at for another question again. So Le and Na again. Le and Na. Le and Na. Let's me carefully thinking about this question first before we are moving to another question. So yes, yeah. So the correct answer is should be A. Only the larger species first. So yeah, it should be A. It should be. I'm pretty sure it should be A. And then the previous one is B. Rubidium. Let me double check. Let me double check the answer. Mm, 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 mm. Which item the largest one? Okay, the answer is okay, rubidium, the C one. And then this is number 10. Yeah, it should be correct. Yeah, it should be correct. Yeah, the concept is same. Okay, the concept is same. Put R in period 2. Okay, put R in period 2, and then Pe has more cation, more positive charge, which is 2. So remember, more positive is smaller, and then more negative is larger. How about the lithium and then Na? How about the lithium and Na? Lithium and Na, sodium. Okay, remember, lithium is only has one shell. Okay, this one is not in the period, this one is in the group. Okay, so like I mentioned, if we are going to top to down, so we will get the increasing increasing of the radius, and then increasing the cell. Okay, this one is just have one cell. Okay, kind of like this one, but this one it has 2 cell. Okay, so Na should be bigger than lithium, so it's incorrect. And then how about the lithium plus and then lithium neutral? Okay, remember, more proton, it will I mean we lose electron, so we lose electron. Okay, so it will give you like more positive charge. Okay, more positive charge, smaller radius, because like I mentioned before, okay, size will be decreasing with the much more like size increase. So remember, more positive charge is smaller radius. More positive charge is smaller radius, because like I mentioned, it will give much more repulsion or force, like much more pull towards the nucleus rather than when we have like neutral atom. Okay, like I mentioned, 3 against 3, it will be different if 3 against 2. So 2 you can illustrate kind of like the orbital, the electron in orbital, so it will tends to pull to the center. Okay, so yeah, based on the concept that we understand that cation smaller than neutral, so this one is incorrect. All right, and yeah, why I explaining some such as this way to make us much more, to make it more memorable. So when we don't understand, like we don't know like which one that correct, we can remember, okay, the concept of like if 3 people against 3 people, 3 people against 2 people, okay, something like that. Okay, and then the last option is S larger than S2 minus. Remember, more electron, it will be increasing the repulsion. Okay, it will be increasing the repulsion, which mean it causing, okay, it causes the larger distance between the shell and then the nucleus. So it is also incorrect. Okay, so the correct answer it should be A. Okay, the last question before we are moving to the practice, but we're gonna do practice later on, not now. Okay, arrange the element L, E, N, A, N, L, L, I, and E, and A, and AR in increasing order of the first ionization energy. First ionization energy. So this one is another concept. Okay, so we already understand the concept of ZEFF. We already have the concept about the atomic radius. We have the concept about the anion and then cation radius or size. Okay, and then now this question asks about the ionization energy. Okay, ionization energy. All right, so we are asked about which element gives up. Okay, gives up. Remember, what's the meaning of the first ionization energy is, okay, ionization energy is energy needed, okay, energy needed to remove one electron. Okay, to remove one electron. Okay, so which element give more easily, like give up more easily electron, and which resists it the most? Okay, increasing order. So we need to find, we already understand what's the meaning of the ionization energy. Ionization energy is energy needed to remove one electron. Okay, the trend is kind of like this one. The trend is ionization, IE, okay, sorry, IE, ionization energy. Okay, the trend is from the left to the right, tends to increasing. Okay, tends to increasing the ionization energy. Because of what? Because of more protons. Okay, because of more protons. And then what? Because it has more proton, so it more tighter hold or tighter pull. Okay, tighter hold from the proton. Okay, because it has more proton, so it more tighter hold the electron that orbits in the shell. Okay, so because of that one, to remove one electron, it need much more energy, right? It should be need much more energy. You know what I mean? So because it's tighter, the it has like tighter force or tighter hold. So to just take out one electron, it takes so much energy, more energy. Okay, because it has more electron. How about the group? Okay, how about the group or from the top to the bottom? Okay, from the top to the bottom. The top to the bottom. How about the trend, right? How about the trend if we are looking at top to the bottom? Okay, it tends to decreasing. Why? It tends to decreasing. Why? Because it has larger size or much more shell, And then as you can see, if we have like much more cell, okay, much more cell again and again, it will be easier, okay, to remove electron from the shell. Okay, so larger shell, okay, larger shell or atoms, okay, or atoms, so it much lower, like looser hole. Okay, so noble gases kind of like NeAr is very high. Okay, is very high. NeAr, because this one is noble gases, it should be very high, very high. And then Le, and then Na, this one is alkali metal, which is like low ionization energy. So now just let's rank from the lowest to the highest. Okay, increasing, remember, lowest to the highest. Okay, lowest to the highest one. Okay, we compare between lithium and then natrium, lithium and sodium. Okay, lithium and sodium over here. So it has more shell. Na, it has more shell. Okay, so it will be having like lower ionization energy. Okay, ionization energy. This one is lower. So the lowest one, it should be Na. Okay, it should be Na because it has more shell. So to take out the electron from the nuclei, from this element, is like easier rather than lithium, because lithium has like less shell. Okay, so it will like tighter hold. Okay, it hold like more stronger. Okay, so the answer is Na. It should be Na, and then lithium. And then now we compare between neon and then neon and then argon. Okay, both are stable, yeah, stable. And then we need to, like I mentioned, which one that has more shell. Okay, we're moving to this part, Na and Ar. Argon has more shell, which mean that like easier. So it should be Ar and then Na. Ar and then Ne, or neon. So the highest one, the correct order is the Na, Le, Ar, and then Na. So the answer is should be A. Okay, just recap. So just recap over here for those question, I mean both question, that cation, okay, cation, okay, shrink, cation shrink, okay, will be shrink, okay, and then anions will swelling, okay, swelling due to repulsion, it will be swelling, so it will be swelling. And then remember, for more proton, smaller radius. Okay, cation will be shrinking. Remember, CS, cation shrinking, anion, AS, swelling. Swelling is bigger. Okay, and then for the last one, how to recap this one? Goes up, okay, across a row. Okay, goes up across a row. Ionization goes up across a row. Goes down across the group. Okay, goes down a group. Okay, noble gases stop the charge. So the last one is very difficult to remove the electron in argon or from neon, but still possible. Okay, so I think that's all for this concept. This is for the practice, and then later on we are discussing about the real question of the ACS exam. Okay, see ya, bye bye. Hopefully it will be helpful for us to remember the concept of the chemistry, like the basic of chemistry. Okay, see ya, bye bye.